homework was easy until I go through the exam review.
In the textbook?
Yeah, the lesson 15 review for exam.
Is it really tough?
Like I'm going through it, and it's like I don't know if you looked at it yet. Like, I was listening to the video that she did, and it was just telling you what to put on your cheat sheet and
Yeah.
going through it. And I thought, oh, I'll just pull this up right before I get on the call. And I'm looking at it, and I'm like, oh my gosh. There's a lot.
There's a ton.
Yeah, I skipped all my classes today to study for this test, and I didn't do any studying, so.
That's how it usually works, right?
Yeah, Netflix was too tempting.
Today's my kid's last day of school, and my son was sick this morning, and I'm like, you have to go to school.
Like, I need you to be gone.
Yeah. He went late, but he went. But the whole morning was occupied by him trying. He just turned 16, so he's trying to convince me to not go to school.
Hmm.
Okay.
All right. I think the understanding confidence intervals is what stinks the most.
Yeah.
Everything else is SPSS, pretty much.
Well, I'm kind of getting down, like, I'm just writing down, like, each step for what specific thing we do, like, when we are deciding on a one sample T, I just made sure I know you're doing explore or paired test. Like, I'm just marking down, like, what the different steps in SPSS is so I don't forget.
That's smart.
So if you go to the review questions on our homework or whatever it's called, because I went through all that. Like you go over at the end on the review, it goes through each lesson recap, which is great until you get to the questions and it starts asking you things where you have to know the difference of what formulas to use, and that's, I think, where we can help each other. I want to write down so I can study that because it's going over, like, number 5 was a factory makes propeller drive shafts for ships. The quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures the length, and finds her sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. So now it goes back to, it's not going over the review, actually it's remembering what formulas to use.
Yeah.
So I think we can go through and just maybe make notes as to what formulas to use or what chapter that is in, that kind of stuff. Because otherwise it's going to take a very long time because this is
26 questions?
26, yeah.
Okay. We can go over it all so that we all understand it and
Okay.
figure it out. You guys all ready?
Yep.
Yeah. I figure we'll go long today, but just to let you guys know, I do have to go at 2:30. But hopefully we'll be done by then.
Yeah, hopefully. All right, I'll read the first one. Given a 90% confidence interval of 45 and 105 for a mean heart rate, which of the following is the best interpretation of this confidence interval? A, we are 90% confident that the true mean heart rate is between 45 and 105. There is a 90% chance that the true mean heart rate is between 45 and 105. 90% of all the people have a heart rate between 45 and 105. And there is a 90% chance that the sample mean heart rate is between 45 and 105. I would say A.
Yeah, I said A too.
Is that contain the true mean? Or the,
It's the confident one.
yeah, the confidence intervals actually contain.
And there's no answer guide for this one either.
I think this is the same thing as the last test where our group quiz is.
Okay.
I
Similar.
might be wrong, but I
Okay.
think that's what it is.
All right, I'll do the next one. It says researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no, go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no, go stimulus required the students to respond to a particular stimulus and not to respond to the other stimuli. Use the information to answers 2 through 3. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence intervals would be reliable, they created QQ plots for both random samples and see that they are approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not?
Okay.
Well, they found out that it was normal through the QQ plots.
It needs to be normal and it has to be a simple random sample, doesn't it?
For this one is for the means. Uh-oh, we just lost Marjorie.
She's back. Her laptop died.
Okay.
Let's see.
A number 1 was A, right?
Yeah.
Okay.
Researchers decided to confidence interval. I would say yes.
So is it B because it says the distribution of the mean of each sample is normal since the data have been determined to be normal.
Yeah, because it is
Because
the central limit theorem the one where the large populations. I don't remember how to state that actually, but I would go with B.
B because they had to do the QQ plots. Don't you think?
What was the central limit theorem again? Was that the large sample size?
That was the X bar over the normal something. It was just in our homework from 14, I think.
This is central limit theorem?
Yeah, in our homework
homework
quiz, I just had to answer one of these yesterday. Oh, here, it was question 11, and it was reject the null. There is sufficient evidence to suggest that there is a different, no wait.
No, I think it was the last question of the homework quiz.
Yeah. Oh, 11, here, 11. I was reading into 6. 11. Here it is. That the distribution of X bar will approximately normal if N is sufficiently large. That's the central limit there. At least that was question 11 on our homework quiz.
And this isn't large because it's only 15, and well, it could be 30 because it's 20 mils and 15 is 35.
Yeah, so
I don't know if it's A or B.
I would say B.
Yeah.
I'm bringing it back up since my laptop died. I had to call you guys back on my iPad.
Sweet. Do we want to go with B?
Let's try B.
Yeah, okay. If it's not B, it's A. But we should probably figure out why. Okay, so of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? I took a picture.
Was the standard deviation known? No.
No, it wasn't.
So confidence interval for mu when a standard deviation is unknown?
Um,
What I mean of differences. Hold on.
oh, this is for hypothesis testing.
Which question number are you guys on? Sorry.
3.
3?
Okay. For the experiment. Okay. Let's see.
So it is either. Are we using independent or I think we're using independent samples.
Well, I'm just looking at, I'm going to try to have you guys look at this for a second. Let's see. If we figure out, let's see, over here, this says it's quantitative. Are there 2 sample or 1 sample? And then we decide if it's dependent or independent, or if it's a 1 sample, then we decide if it's an unknown or a known, if that makes sense.
Well,
And then that,
this one has 2 samples because it has female and male.
okay, so then we decide if it's dependent or independent on which test we're going to do.
Okay, so I think it's independent because it says stimulus of males differed from that of females. 20 females, 15 males. So like they can't just choose a male and then have a female paired to him.
Yeah, it says also they decide to construct a confidence interval to determine if the difference of the means is significant. So we're doing the mean of differences or differences of means, and those are C and D. So you think it's independent?
I think it is independent.
Okay.
What'd you say, Eddie?
Independent. Because
Okay,
they're
yeah.
not
So
they're not
D,
picking females depending on what males they choose, or vice versa.
Yeah. Like, I mean, if it was husbands and wives to see like of different couples, I think it would be dependent.
Yeah.
But
So
I think
that
it's
goes along.
independent.
That's what I was thinking, but that goes with the matched pair one. So I don't know.
Matched pair. What do you mean?
On lesson, the paired data, that's on lesson 12.
Oh, like if it's a two sample paired test or a two sample
I don't know,
independent.
like independent or dependent. But we'll just do independent and we'll see if that works.
I think yeah, it is independent. According to my notes from the video.
all right, so we're going D.
Yes.
And 4, a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. 95% confidence interval for mean savings account balance of bank customers is found to be blah blah. Which of the following would produce a confidence interval with a smaller margin of error than the 95% confidence interval?
So if n goes down,
Would it be the
then
C, the compute a 99% confidence interval rather than a 95?
For a smaller margin of error, it would have to be a lower percentage.
Smaller margin. If you're 99% confident, you're gonna have a smaller margin of error if you're 95% confident.
so increased percent equals decrease in margin of error. Yeah, because right here I have that the margin of error increases, then the confidence interval gets bigger.
Yes.
Okay.
Obtain the balance of 90%.
So are we going with C?
I think C.
Because I know A is wrong. So if you increase, what about B?
Obtain the balance of 90% bank customers rather than 30%.
Because if you increase the number of people, your confidence interval gets smaller.
That's true. Yeah, if you increase your sample size, your confidence interval gets smaller.
Yeah. So I would say probably B.
Yeah, let's do B.
Okay.
Be the unknown.
Bless you.
Excuse me. All right.
So now 5.
5.
I'll read number 5.
Okay.
A factor makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate a 95% interval to the true mean for the true mean length of the shafts.
Okay. So we have, so she selects 4 shafts. Sample mean is 1,000. Lengths are known. Normal distribution. So we know the standard deviation.
What's
Okay.
what's the formula for this one? What's the standard deviation? It's 2. Okay, it's 2 millimeters.
The formula I think that we're using is where is it? It's something plus or minus, where is it?
Oh, it's X bar plus or minus Z times the square root, not square root, the times the standard deviation over the sample.
Square root of n. Yeah, that's it.
All right, I'm going to write that down because I was looking at that. I'm like, oh my gosh, that's so much information for my brain right now. Plus or minus Z star times standard deviation for n.
Okay, so we are looking for the confidence interval, right?
The confidence, yeah, and the Z one is the 1.96. So
Yeah.
what's the X bar? Is that what we're trying to find?
That's the sample mean, which is 1,000.
Oh, okay, 1,000.
Plus or minus 1.96 times the standard deviation is 2 over the square root of 4.
4?
Yeah.
And my calculator's on.
Okay, so I got A.
1,000. Right. Me too.
Okay.
Yep. Something that the TA had told me is that just to watch what confidence levels they are, because she said most of the time in the homework it's always 95%, but that it won't be in the quizzes.
Okay.
So that, like here when we're doing the actual manual formulas, we need to make sure we're putting in the right Z or whatever, and then also in the SPSS that we may need to go in and change that statistic. Anyway, from something other than 95.
Yeah. Sounds good. So that actually wasn't too bad, now that I
Yeah.
think of it. All right. I'll read 6. To assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighted a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and a standard deviation of 0.01 grams. How large should n be so that a 95% confidence interval for mu has a margin of error of plus or minus 0.0001? So do we use that n equals formula? Where it's n equals z times the standard deviation over m
I
squared?
think so.
And then the square root or square rooted. This for the
Wait.
sample.
Is it squared? I thought it was squared.
There's no. I don't think the n is
Square.
z with the standard
Sigma.
deviation
This
times
one?
the standard deviation over the margin of error.
Uh-huh. I have
this-
it all of it squared. Is that wrong?
Yeah, right here. Is
Where is
that
it?
what you're talking about, Catherine?
Oh, yeah, yeah. Okay, I thought you meant square root.
Yeah, sorry about that.
Okay, it's all good.
What was it again? N equals.
Z times the standard deviation over the margin of error squared. All of it squared.
Okay, so z is
Is it 95? Yeah, so it's 1.96
1.96 times
times, so we give it 0.01.
0.01 over 0.001
0001.
equals.
Okay, I got C.
Oh, I did. Hold on.
Sorry, what was the formula again? 1.96
Times 0.01,
over.
0.0001,
Uh-huh.
and then all of that squared.
Oh.
I didn't get the answer, and I don't know what I did wrong. So I got 1.96 times 0.01
Mm-hmm.
over 0.0001,
Mm-hmm.
which equals 0.0196.
No, it equals 196.
Did you put parentheses?
Yeah, I got 0.0196 just by doing 1.96 times 0.01.
Yeah, and then that's over 196.
No, that's over 0.001.
Oh, I'm sorry. I don't know what I just did there. 0.001. Okay.
Yeah, I got the same thing. See.
See? Okay.
Okay.
Did you get it, Marjorie?
Yeah. Well, I use the C.
Mm-hmm.
What I was getting.
All right. Did you get it, Donna?
Yeah, I just have a decimal point, and I don't know why.
Did you do .0001 or .001?
That's why.
Okay.
I'm sorry my volume's up, but my daughter's not home, so I have to make sure she's getting home okay.
That's all right.
She just texts me it's summer because it's her last day of school.
Oh, I wish I was in summer.
Me too.
All right, should we go on?
Yeah.
Yes.
We're on 7, right?
Yeah. The mean area mu of several thousand apartments in the new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The appropriate null and alternative hypothesis are
I did A.
To
they're wondering
be,
if it's less than what is advertised.
So we put
yes.
Yeah.
okay.
Yeah. I would say A2. I think the hard part with these is when they give you a different test and they don't tell you what test it is, and they ask you
Yeah.
to find the null and alternative. Just like, I don't know. Okay.
All right, number 8. In a statistical test of hypothesis, we say the test result is statistically significant at the level of significance if
Statistical test.
The p-value is
Less?
less than alpha. No,
no, I thought it was larger.
if I think alpha is larger than the p-value.
If it
Value
is statistically significant, like if it's above.
Yeah, so B,
B.
yeah.
Okay.
A group of statistics students wants to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 from each of the different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample standard deviations are nearly equal. Can you use an ANOVA hypothesis test to answer their question?
No, because this is 2 groups and not more than 2 groups. Oh, it's 4 different apartment buildings. Just kidding.
Yeah, there's 4.
So yes.
We can, let's see.
Yes, the data bill should not.
So it talks about being normally distributed, that's bell-shaped, and the variances are equal for each group. If this says nearly equal, is that okay?
Yeah. I don't know. I think so.
Standard deviations, not variances. Is that the same thing?
Oh yeah, the variances are equal. This is standard deviations.
Oh.
So maybe we don't have enough data. I don't know. They do not know the true standard deviations of each sample. No.
We don't really use standard deviations in ANOVA, do we?
No, we just use a variance and normal distribution.
So we don't have enough data?
I would say it's either A or C.
C?
I think I want to say it's A. But an A nova is not bell-shaped, right?
A nova is normally distributed. It's not bell shaped, it's right skewed.
Yeah, it's
Yeah.
always right skewed.
So we don't have enough information. No,
Yeah.
we don't. They don't know the standard deviation for, yeah, so no, we don't have enough information.
Yeah, I think so. I think we need to know the variances to actually
Yeah.
know. Okay, so let's go with C for 9.
So that's important to know. It has to be bell, if it says it's bell shaped, it's only right skewed.
Yeah. Oops.
Okay. A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries a new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the null hypothesis would be rejected at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of patients with a particular type of cancer. The researcher has committed, is it type 1?
I'm going to draw out the table really quick just to clarify for me. Okay, so she, even though the sample is small, she rejected. Oh, so she rejects the null hypothesis. She rejects the null, but then she finds out that, so it is a type 1 error.
When you reject the truth is when it's a type 1.
Yeah.
Can you show me your thing, Catherine? I'm forgetting how to set it up again. The reject is up top, fail to reject is below,
Where is
and
it?
then hypothesis, okay.
It's backwards, I realized. Is it a type 1 error? Or she finds out that the
Type 1, and then
It rejects the
type 2.
null, so yeah, it had to be a type 1 error.
Okay. Did you get it, Marjorie?
Yeah.
Okay. So we're gonna go.
A.
Yeah, we're going with A.
A. If the level of significance in the area is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error? Okay. By making the probability of committing a type 1 error very small, what happens to the type 2? By reducing the probability in committing type 1, we also reduce.
I remember this being in one of the lessons.
C, like they don't affect each other?
Well, if you reject one, then you fail to reject the other, right? If you don't reject, then you fail to reject, so it's either. So I would say that if you lower the probability of committing a type 1 error, then you increase the probability of committing a type 2
Was
error.
it A or D?
I
I'm
would
going with
say
D.
D.
You want B, Eddie?
No, D.
D.
D as in dog.
Got it, dog. Let's go for it.
All right. I'll read 12. The nicotine content in cigarettes of a certain brand is normally distributed, with mean in milligrams, sigma, and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? I'd say yes.
So reject the null.
Where is it?
So D.
Or
If P is low, then no, we fail to reject the null.
Is P is low, reject, is it reject the null or fail to reject the null?
No, if P is low, reject the null.
P is
So we're
low,
failing to reject.
Yeah, we're failing to reject. So B.
how?
P
For-
is
For
low.
12?
Yeah.
Okay, so the sample mean that they got is 1.53, and that is bigger than their,
1.5.
yeah.
Does a standard deviation come into play? Because it's at 0.17.
So there's 1.5, and the alternative was a 1.53.
Yeah. So it is bigger. It's not less than. You see what they have up there? Oh, I guess that's not a p-value, is it? We can solve for it.
Nicotine content for cigarettes of a certain brand is normally distributed with mean.
What would we solve for?
That's I don't think we can.
Because look at there, it gives you the null is 1.5, and the alternative is greater than 1.5, which it says is right there. So you would reject the null.
Fail to reject the null. If it was under 1.5, you would reject the null.
Oh, I see where you're coming from. So the mean that they got was, so the null hypothesis was that the mean was equal to 1.5.
Right.
But they had a large, simple random sample where the sample mean was 1.53, and their null hypothesis was that the sample mean is larger than 1.5. So we reject the null.
Or
So it
do
would
we
be,
fail to reject because we assumed that the null, that the alternative was already more than 1.5?
That's kind of a tricky wording because with the null hypothesis, it's always either or. There's no like assumptions.
I would say reject the null if it was alternative of mean equals or not equals, or yeah, if mean would be equals to 1.5, would that be reject?
But I also see where the other ladies are coming from, saying that it's above, so we fail to reject. But the wording, if it says assumed,
so
I just know, I remember from before, they said like, you don't make assumptions. It's either this way or that way with the null, either above or below.
I say let's reject the null. Because we don't have a p-value. I don't know. That's a tricky
Put
one.
B or D type of thing.
Yeah,
Let's
it's either B or D.
Let's do B first. Do we get to do this more than once?
I see. If it's this quiz, then yeah.
Okay, so I'm going to circle B and then I put or next to D.
Okay.
Yeah.
Okay. You would
All right.
like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 for each group and test if those means are different. What is the correct statistical procedure? This is matched pairs because we have to have a male or female. Because if you're doing worked wages per male student and female, you have to have female to have male or male to have female, right? It's not a one sample.
No, because there's two samples, but I think it's independent sample test because if you do a female, it doesn't mean that you get the male's salary, you know? Like choosing a female doesn't give you the male. So that they're not dependent on each other.
But if you were to do a sample of pre and post, are they dependent on each other? Because you're doing one before and one after, and this one you're just one male and one female.
Are they, let's see.
Or husband and wife, like if you're doing comparing salaries between husband and wife, you need to have the husband to have the wife, and you need to have the male to have the female.
Yeah, that would be matched pairs.
Yeah.
But right here, it's just male students and female students. So if you choose a female student, her wage doesn't affect the male student's wage.
Yeah, I agree.
So I would go with D. Yeah? No?
Let's go with independent.
Okay.
You want to read, Eddie?
Yeah, an educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling?
I'd say dependent.
Is it D?
Let's see. A sister's academic achievement depends on some. Nope. She select a brother to compare to his. Yes. Because it's brother sister pairs. Yeah, I would say it's D. Because they only want to use brother sister pairs.
Yeah.
So I'd say D.
Okay. Questions 15 through 26. Select and carry out the correct. What is inferential procedure for each set of problems? A soil scientist collected random soil samples from a field and measured the dissolved organic carbon levels of each sample. Dissolved organic carbon molecules are an important part of the ecosystem and help plants to process organic compounds. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. So we need to open the data file dissolved organic carbon, use the information to answer questions 15 through 16. Of the 4 types of confidence intervals listed below, which one is appropriate for the situation? Do we have a standard deviation known? There's no standard deviation.
So B? Or is it dependent? Let's see. Is it known? It doesn't say that well, one thing I'm looking at is this thing that separates them. If it goes over to a 1 sample, then it's either a known or unknown. If it's a 2 sample test, then it's either a dependent or independent.
carbon levels is one thing. Is it independent then?
No, thinking just. Well, it's only independent if it was a 2-sample test, or it can only be dependent or independent if it falls under the 2 samples.
Let's read it again. So, a soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. Dissolved organic carbon molecules are an important part of the ecosystem to help plant the process of organic molecules. Researchers would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field.
It says sigma unknown because for the 95% thing, we're needing to know.
Are we supposed to open this data file?
I just clicked on it apparently.
But there's only one column of, I mean, if anything, it would be independent because there's not compared to anything. I mean,
I would say it's dependent, wouldn't it? Because the organic carbon is dependent on whether there is, it's an important part of the ecosystem for plants to process organic compounds. I don't think it has anything to do with sigma. I would say it's C.
C.
you think so? Because my only question is if in all of the problems that you're using your 95% confidence interval, and that's in like lesson 10, were we talking about dependent or independent?
I don't know. Let's see. So it says to open up the data file, but what are you supposed to do with it? It's like
that one's not for 15. I think this one's just a question of the 4 types of confidence intervals listed below. Which one is appropriate for the situation? So on the confidence interval, where mu, let's see, where mu and 0 is known. Well, we don't know the standard deviation. I don't know. Sigma.
So it's either C or D. Are we just going back and forth between if it's dependent or independent? Because there's no talk of the sigma.
I would go with C,
Okay.
but that's just a guess. Okay, for 16, they want a 95% confidence interval. So
1.96 plus or minus. Oh, we have to find.
We do the analysis thing, don't we? In the dissolved organic.
Yeah. Okay, so let's see if this gives us something. Okay, so I got the everything. So do we solve this by hand, or can we do this?
The confidence intervals, did you get the 11168 and then 15.217D?
Oh, I haven't gotten the confidence intervals yet.
Oh.
How did you get the confidence? Did you solve by hand?
No, I just went into Analyze and then Descriptive Statistics, Explore, and moved over to the dependent list, dissolved organic carbon levels. And then it automatically brought it up for me.
Got it. Got it. So yeah, I would say it is. Where is it? 11.168 and 15.21.
Yeah.
All right, so 16 is D.
And how
I'll
do you
wait
find
for the next one.
You went to Analyze, Explore. And then you just push, okay.
Just to bring up those that confidence interval. Oh. A random sample of Hummers for sale in Los Angeles and New York were taken from listings at cars.com. We want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles, Group 1, so we may need to, and Hummers for sale in New York, Group 2. Create a confidence interval for a true difference of the mean different listing prices between the two cities. Open the data, use Hummers, LA, New York. Use this information to answer these questions.
Okay, so
Well, the first one we can just answer, and then someone go ahead and do the
I'm opening up the file right now. If it opens. What was it called?
Used Hummers.
Used Hummers, LA, New York.
Got it.
Okay, so this is the one that we need to group. Oh, so we need to transform, auto recode. So what are we trying to find though?
Well, the first question, we don't need to
Okay.
necessarily use it because we're just
Yeah.
deciding if it's a confidence with the known or unknown, same thing, or the difference, if it's a dependent or an independent samples.
I would say dependent.
I think it's dependent because we're going off the prices and statistics of other dealerships, right?
Yeah.
Okay.
Because whatever you get in LA, you'll look for in New York.
And then
Okay,
in the
so
data,
prices?
So for 17, are we doing C?
Yeah.
Okay. For 18, we want a 95% confidence interval. Okay, so are we doing for dependent samples, we do,
Do we need to group this or not?
no.
Yeah.
No.
let's see.
It's already, because it says Hummer, it says Los Angeles, and then it says New York.
Okay, so
We're going to use city. We're doing city and price, right?
city is your dependent and factor is price.
Yeah.
Oh, my computer's so slow. Oh, it's telling me I can't do city independent.
No, you're doing price for dependent. Where's price? And then the factor list is going to be city.
Okay.
Yeah. And we want a 95% level. Statistics.
Okay, so that would be
Okay, so I got
I didn't get anything like we should have.
I got different confidence intervals for both of them. I got one for the price of Los Angeles and one for the price of New York.
Los Angeles and New York, but none of them are negative. Did you get any negatives?
No. Let's see. Which of the following is the 95% confidence interval for the true differences of mean listing prices between Hummers from LA and New York? Okay, so what if we do for, is it New York from LA from New York? Okay, so for 38.
Getting into it now.
38,249.98 minus 43m. Um, what if we do a, for dependent, do we do a, let's do a sample test. Analyze, compare means, a paired sample t-test. One sample t-test. Let's try
I did the
paired.
one sample. I did the one sample and it didn't come up with what we need. So
Okay, I'm doing the paired right now. Well, we can't do paired sample. Let's do independent. So test is the price. The grouping is C.
You're doing it again.
Then we're out of insurance. And we were thinking $80 a month anyway to pay to her. So this will just be what we pay to her. Okay. And my inhaler's $25. That's really good. Well then, I want to go to Walmart quick.
My SPS had gone away in the analyze. What did you guys use in the dependent and the factor? The price in the dependent?
For
we're
what?
still trying to figure it out.
The 18.
Just a second.
What if we tried doing? Okay, so I figured out the mean and stuff like that earlier for this. Let's see. Maybe I didn't. I thought I did. Analyze.
I've done so much. I think I'm gonna delete it all. Yes. Otherwise, it just gives me too much.
Oh no. I feel like this should be an easy question.
Difference.
There's a true difference of mean listing prices between Hummers from LA and New York. Oh, let's see if I can do this. Analyze.
Is there a way, because they wanted differences, right?
Yes.
So is there a way to do the compute variable for differences?
I subtracted them to see if that did anything, but it didn't.
Oh.
No. Oh, what if it is 947? 615. It wants it for the mean listing. Okay, so 41.4. I don't know.
Last time, did we have the exact same questions on the quiz?
I think so, yeah. Yeah, we did. Yeah, we did.
Well, do you guys want to come back to this one? I don't know if it'd change anything from like knowing how to figure it out.
Let's put B. I feel like B is the answer.
I just don't know how to figure that out.
Yeah, I'm gonna write a note, go back.
I'm gonna put a
Yeah, I've
no.
written it down. Because it seems like it'll be some super easy thing that someone will be like, oh, you do this, and
It's like, oh, thanks. All right, let's go to 19. These should all be pretty easy.
bone exercised bone density. Okay, many studies have suggested that there's a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effect of jumping on bone density of growing rats. Jumping? Effect of jumping on. There were 3 groups of rats were selected at random for 3 groups. There were 3. Okay, a control with no jumping, a low jump group, and a jump weight of 30 centimeters, and a high jump group of 60 centimeters. After 8 weeks, the 10 jumps per day, 5 days per week, and the bone density of the rats expressed million centimeter 3 was measured, and the rats were selected at random for the 3 groups. Researchers would like to perform an hypothesis test to determine if the mean levels of the bone density are different between the 3 different groups of rats listed above. Use a level of significance of 0.05. Open this data set to do this. Okay, well, first of all,
I think we're gonna do an ANOVA test for this, right?
Yeah.
Okay.
oh yeah, because ANOVA is always 3 samples or more.
Yes.
I remember that. And I have it written in my little cheat thing here. So an ANOVA is always.
Yeah?
Yeah.
What were you saying, Eddie?
So I found number 18.
Oh, you found it?
Yeah.
How'd you
What'd
do
you
it?
So that's an independent samples t-test.
I did that. It didn't let me do that. Really?
And then if we put city code, define the groups.
City code?
Uh-huh.
So what test did you run on it?
Analyze independent sample t-test for means.
And then you put in the city code?
Test variable price and grouping variable city code, and then you define the groups as 1 and 2.
Wait.
You
So
did have
for
to do it.
what'd you put for dependent?
Dependent? There's
Or
not one dependent.
independence?
Oh, I put so I went to analyze, compare means.
Compare means. Uh-huh.
Independent sample t-test.
Uh-huh.
Move over for test variable price.
Test variable price.
And for grouping variable, city code between Los Angeles and New York.
Uh-huh.
Then you define the groups. 1 is 1 and 2 is 2.
Uh-huh.
Then you okay that, and then you'll get the independent sample t-test graph.
So what was the answer to 18 then?
It was 769 or 770. And
So A?
for upper, it would be 5764.
Okay, cool.
All right, you did the compare independent and then the test variable price in the dependent, and then the group code was city code, and then the 1 and 2.
Yeah.
Test
I don't
variable.
know exactly
Okay.
how in the test I'm going to be able to figure out on my own what to pull over. But I guess we just keep trying different ones until we get the right one. I mean,
So for-
until we get one of the options, I guess.
For 17, would that be C?
Yeah,
mean,
that was C.
D.
B?
D, since we did independent samples.
We want to
Are you
know.
talking about
Oh,
17?
for 16, you're talking about 16.
Sorry, 17.
17. Oh. Of the
Yeah.
4 types of confidence intervals.
So
Is he-
you're thinking it's D?
Yeah, because he ran an independent
You ran
t-test on.
in an independent.
Mm-hmm. So we'll do D. That makes sense. All right. So for 19, we put E, right?
Yes.
Okay. I'll run an ANOVA test. Well, we need to separate into groups. Transform. How do I recode?
I'm in the data sets. What is it called, you guys?
What is what called?
Oh, what's the test we're doing? I just don't have it up.
ANOVA?
No, never mind.
Okay.
I'll just look. What data file? That's what I meant. Bone density.
Exercise bone density.
Yeah, sorry. Dependent list. Okay, so I got it. The test statistic is 7.978.
What did you put in to get that one?
I just ran the ANOVA test, but I found out that F is the T.
Yes. Whenever you're doing an ANOVA, the F is the t-test.
If you do the automatic recall, right?
Yeah.
Okay.
So, did you get C?
Yeah, I got C.
Okay.
And then for 21, I got B.
21. Where's P?
It's the SIG.
Oh, yeah, and you don't divide it. Okay.
Mhm.
Sorry, what was 20 again?
20 is C.
Uh-huh.
21 is B. And we are going to reject the null, so there is sufficient evidence to
B.
B. I say B because whenever you're doing the ANOVA, if it has the wording, oh wait, at least of the groups. Let's see.
At least one of the groups.
at least one of the groups.
And we know that it's sufficient evidence.
Yeah.
Because the other option would be E, but that's insufficient.
Okay. Cool.
So,
All right. Direct flight costs.
Oh, another one.
It's the last one, guys.
Let's get out of this one.
I'm opening it up real quick.
Where's the correct one?
Direct flight.
all right, I'll read it and we can decide what test. Pressures of supply and demand act directly on the prices of an airline ticket. As the seats available on the plane begin to fill, airline raise the price. If seats on the flight do not sell well, the airline may discount the tickets or even cancel the flight. A study has undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of the scheduled flight compared to the ticket purchased only 14 days in advance. Data were collected on the cost of one-way ticket from London airport to the destination to a variety of destinations in Europe. The lowest published ticket price of one-way flights from Heathrow non-stop flights, then tickets are purchased, let's see, 90 days in advance compared to the 90 days in advance. Use the level of significance of 0.10, open the stat, use the information to answer these questions. Oh my goodness.
So it is a. Do you guys know what? Let's see. It's not an ANOVA test.
No.
Is it a dependent? Because
I think it's dependent on the how early you book your flight.
yeah,
Right.
because the sample itself is
Oh, so it's dependent on whether the seats fill up fast or not. So if the flight do not sell well, then they discount the tickets. So I would say it's C. Right? No. Let's see.
Do we need to group this one? What's the difference between
No.
14 and 90 days? Hit list, factor list?
14 days in advance compared to 90. 14 and then let's see what it gives us. Okay, so
What did you put in?
I'm gonna say it's, what test did I do?
I think it's a one sample t-test.
I did paired sample t-test.
And what did you get?
So I got T for the test statistic. I got A.
So you did a paired sample t-test?
Yeah.
So did you put these in groups then?
No, no, you don't need to. So for 23, I put C. For 24, I put A. For 25, it wants to know if it's different, right? There's a difference. So you just leave it as 0.096, which is B.
I don't understand how you got there. So when you get done, I'm trying to look at this and analyze it, and I don't know where you are.
Okay, so do you want me to walk you through it?
Yeah.
Okay, so go to Analyze, Compare Means, Paired Sample t-test.
Yeah.
Okay, then I moved over the 14
Mm-hmm.
into variable 1, pair 1, and then 19 into variable 2, pair 1. And then I just clicked OK.
You didn't do a differences row?
No, are you supposed to?
Well, it says determine if the difference of the cost.
How do you make a differences row?
When
You
you
go
do the,
Yeah, I think this is a wrong, I mean, I think you got right information, but you need to do,
compute variable.
yeah, compute variable, and then do difference.
Wait, where do you get
yeah,
compute
type
variable
in the
from?
actual word difference.
Yeah.
Transform.
So you go to transform, compute variable,
Uh-huh.
and then
And then you move over the 14 days minus 90 days.
14 days minus 90 days.
And type and label, you'll put in on target variable, you put differences.
Differences?
Uh-huh. And you okay that.
Okay. Oh. Transform compute variable.
And then you do analyze, or what?
Yeah,
And
analyze, compare, and then you go in, don't you do a one sample T at that point?
Is it a
yeah.
one sample?
Uh-huh.
Yeah, because then you do
Okay.
difference, right? Test
Yeah,
variable.
Uh-huh.
calculating differences.
And then
Okay.
make sure the test value, if it's just 0, keep it 0, but whatever the test value is, whatever the null is. And then also, these were just from my notes. Also, we always need to make sure that the options, if we need to change the confidence interval, make sure it's still the 95, or, if they didn't specify something different.
Yeah. Okay, so.
Yeah, these were my notes for a paired test.
Okay, well, 24 and 25 are still right.
Mm-hmm. Yeah.
So since it's 0.1, we're going to reject the null and say that there is sufficient evidence.
There is.
Conclude that there is a difference, right?
So B.
I think so.
Does anyone else disagree? I would
B.
go with B.
Yeah, I say B too.
Okay. Well, hopefully the group quiz is the exact same thing.
That would be nice.
Let's see.
Group meeting quiz. Okay, we going for it?
Go ahead and put a test too.
Did you see the test on yours?
Let's just go ahead and take the test.
Oh, no, I'm not ready for the test yet. All
Okay,
right.
let me get out of this again. Hold on.
Okay, I think it's the exact same thing. All the files are the same.
Okay, group meeting quiz for 15.
It's the exact same.
Awesome. I just want to make sure I got them all the same as you guys. It looks like I didn't write down for 14 and 15 for some reason, but we'll get there.
Okay. So I have the review open just so that we know what questions are being asked. So 2 is
B.
A.
Hold on just a second.
It'd be B on the quiz.
Is it B on the quiz?
Yeah.
Oh, dang. Okay, we are 90% Well, I have the review open, so we're
You
good.
have it open because all I wrote is the number and what letter we put next to it.
Yeah, so okay, good
So
catch.
it's B, right?
Yeah, 2 is B.
I think if we all double check, we should be okay.
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 So then the next question, we put B, which is yes distribution, and then it ends in normal. So yes distribution, so it's C.
It's C.
Okay, so question 4, we put D, which is confidence interval using independent samples.
D.
It's C.
Compensate for mu when what are you saying it is on the test?
Question 4 is C.
C?
Yeah, C.
Sorry, I couldn't hear you. A thing came up on my iPad.
C.
You said C?
I said C.
Thank you. Sorry. There's activity days in an hour for my girls. Had a thing pop up.
Okay.
Okay, 5, we had A, but what does that mean? Let's see.
Wait, have we done 4 yet?
4. You need to do 4, and it's
Yeah, we had B.
it's
So
D.
Is it D?
Whoa, whoa, whoa. Then I messed up here.
4 is D, yes.
4 is D.
No,
Wait a
no,
minute. No. 5 on your test. We're on 5 on the exam, but 4 on our test.
Got it.
Okay.
5 on the exam is D.
D, yeah.
Obtain the balance of 90 bank customers. 6 on the exam, the margin of error.
So that one we put an A, which is 998.04.
Comma.
998.04, comma,
Yeah, we're trying to look for the confidence interval,
yeah,
and that one should be our upper bound, right? And 7 is going to be our lower bound.
no, an interval is,
The margin of error.
question.
Ooh, this is tricky. Okay, so you need to do the what was
Did we
that?
not do this?
We need to divide it by 2, the upper bound and the lower bound.
Yeah, in parentheses, upper
Wait,
bound
what?
minus lower bound, then divided by the 2.
Upper bound minus lower bound divided by 2. You're right.
Equals
So
the margin of error?
Yeah. That gives us that
Okay.
middle portion.
8.04 minus. Did you guys get 1.96?
I don't have the intervals in front of me. Let's see. Oh, here it is.
Negative 1.96.
I got positive 1.96.
me
Yeah.
too.
You guys said it's upper minus lower, right?
Yeah,
Yeah,
that's
upper
back.
minus
Positive.
lower.
It's positive.
Yeah, 1.96.
Yeah. Okay, and then for 7 and 8, you just input the answer we
Is
got
it the
for 5 on the
99?
review.
Okay, 998.040.
Mm-hmm.
And then the upper was the 1001.960.
6.
Okay, then 9 on the quiz.
Is 38416.
38416, no decimal.
No
No.
decimal. Okay, and then 7 we put the less than 1. Equals and less than. So
So
it's C. Or D. It's D.
B. D?
D.
Oh, less than. D.
Right, and for 11 we put the
B.
p-value is less than alpha.
B
Mm-hmm.
on 11.
For 9 we put
Or 12 in the quiz.
yeah, no, they do not have enough data. So it's B on 9, or 12 on the quiz. Okay. So medical researcher. The next one we put committed a type 1 error. So A. For the next one, we put by reducing the probability of committing a type 1 error, we increase the probability of committing a type 2 error.
So A, right?
Yes. So the next one we put
Recheck the null.
we put B, which is reject or fail to reject the null.
Yeah.
That's
we
what we
were
circled,
A or
right?
we weren't sure, remember?
Yeah.
Or is this the one?
We circled fail to reject first though. So if we can retake it.
Okay.
Right. For the next one we put independent samples test. Okay, the next one is dependent sampling, and it ends in study.
So D.
Dependent and ends in study. Yes.
So 17 is D.
The next one is confidence interval for the mean of differences using dependent samples.
So B.
So D.
D.
Or using there.
Okay.
D. Innate.
So for the next one,
We have to do
we
the
have to
error
solve
again.
for the margin of error.
For that math again.
So we had 15.217 as the upper bound and 11.168 as the lower bound.
What was that again?
15.217 as upper, and then the lower bound was 11.168.
11.168, and upper one was 15.
0.217. Okay. I got 2.02.
Did it say anything
5.
about, are we supposed to round it off to the third place?
I don't know.
Sorry.
Can someone scroll up? I have mine matched with the review right now.
I don't know, I'd say 3 decimal places won't hurt.
Okay. Unless it specifies, right?
Yeah.
So the lower bound is 11.168.
Mm-hmm.
And 15 or 21 was 15.217.
You mean the upper bound?
Or yes, the
Yeah.
upper. And
Yeah.
sorry, what was the margin? Who did the
I
math?
got 2.025.
No. Say that again. Sorry.
2.025.
2.025.
Yes. And the next 2 questions, you're just writing them in.
Lower bound 11.168, upper bound 15.217.
Mm-hmm.
And then on the exam or quiz, 22 of the 4 types of confidence listed below, which one was appropriate? This was for the Hummer one.
What question are you on? Are you on
20.
question 22 of the quiz?
Yeah.
I don't see any Hummer here. I see of the 4 types of confidence intervals listed below, which one is appropriate for the situation?
Yeah, but it's taking off of the Hummer data.
Oh, okay. Well, for that one, we got D, using independent samples.
So it's C, right?
Confidence
Yeah.
interval means using dependent.
Okay, so for
Or
the next one, we're doing independent. For 22 is
22.
independent. Yeah.
That's all we have to do when we find a car show.
Okay. For 23, the lower bound is -770.
No point.
No point. And the upper bound is 5764.
5764.
That one did actually have decimals when you pull it up, but they rounded it on the actual review.
Oh. I'm just using the ones on the review. Should we use?
Probably should.
I don't have the actual answers. I just have the A.
Yeah. Which one was that one? The Hummer?
The Hummer?
The 24, the upper bound was 5764 on the review. I'm just going to go with it.
It should be fine, right?
Let's see.
I think so.
Because when I checked that there was actually they rounded it at the review, but I don't think they want to round it here.
This one says round to 3 decimal places. Do you still have it up, Eddie?
I just pulled it up, and what are we doing again?
We're the 95% confidence interval.
And we're doing an automatic recode, right?
Yes.
No. Is this an ANOVA test?
This is a group 1 and 2, and you have to do the independent t-test.
You did compare means. You did analyze, compare means, independent sample, t-test. And for the test variable, you put price. And for grouping variable, you put city code. And then you defined group 1 as 1 and group 2 as 2, and then you pushed OK.
Oh, I remember this. Once you get it, tell us the lower bound and upper bound. We'll see.
And that one was a paired sample t-test, right?
No, it was an independent sample t-test.
Okay.
I think they let you have a margin in there. I think they'd let us just put in what they put in for the review.
All right, I got it.
Okay, what'd you get?
So for lower bound,
Mm-hmm.
it was 769.741.
Was it negative?
Negative. All of that is negative.
Uh-huh. And for the upper bound?
And for the upper bound is 5763.839.
Mm-hmm. 839.
5763.839. And what was the lower again? Negative.
Negative 769.741.
Okay.
Say at the point after the decimal again, please.
0.741.
741.
Mm-hmm.
Negative 769.741, and the other one was 5763.839.
Yes.
Thank you for running that again, Eddie.
No problem.
Okay. So 25 on the quiz is ANOVA. And the test statistic is 7.978.
7.978.
Mm-hmm. Okay, the
And the
p-value is 0.002. Okay, and for the next one we put there is sufficient evidence to conclude that the bone density of at least one of the groups is different from the bone density of at least one of the other groups. So it's sufficient with at least.
That was B, right?
No, it is D.
Sufficient evidence. Yeah, we need that at least in there for an ANOVA.
Okay.
Yeah. Okay, for the next question, it is a dependent samples test.
Or was it a one sample t-test?
We put dependent for that. Oh, we changed it, didn't we? We used a one sample.
We changed the one that was in.
It was the last one, yeah. So, do you guys want to do independent? Oh,
I guess we'll check.
we did a one sample t-test for this, so it's B. I wrote it down. Yeah, we did.
Wait. For
one sample
29s, we did a
is
one sample
B.
T.
We did a one sample t-test for number 29.
So it's D.
Yeah.
Okay. Okay, and then the F, the test statistic.
Is 1.685.
85.
The p-value is 0.096.
0.096.
Mm-hmm. And the last question is, there is sufficient evidence to conclude that there is a difference in the cost of tickets purchased 14 days in advance compared to 90 days in advance.
B.
There's
B.
sufficient evidence. Okay.
B as in boy.
Yeah.
All right. I'll go for it.
Okay.
Uh-oh. Darn.
What?
Oh, stupid. Let's see. I put a comma somewhere.
Oh, I put a comma too.
Where?
Wait a minute. I got a few wrong here. Says I
What?
only got 23 right.
Out of 32?
Dude. Wait.
Let's go through them before we all.
Yeah, tell us which ones are wrong.
How many
All
commas
right.
did you use?
Okay. 29. The
Oh, hold
one
on.
sample T. That was wrong.
29?
Uh-huh.
For 29, we had put down something else, right?
We put independent is what we had down, or deep. We had,
We had
Dependent.
for
depend.
23, we had dependent, yeah.
All right.
So
Well, you guys keep that and tell me when I
Okay.
come back to and fill in all my answers again.
Okay. Which other one?
Let's see, 24. My answer, for some reason, I put a comma in here. 5,763.839.
Okay,
Are
so
the
that one's
numbers
probably
correct?
right.
Yeah. But,
Okay.
and then, and then the other one, 23, I got wrong. The negative 769.741.
That's wrong.
Mm-hmm. I think we should just put the answers that they had.
The 770,
Yeah.
negative 770.
Anyway, that's my guess. But both of
And
those were wrong.
5764, right?
Yeah.
Okay.
And
Okay, which
then,
other one?
okay, maybe I just put it in wrong, but 19, 2.025.
That's what I have.
Okay, it says it's wrong.
Okay. So 19.
And then 18.
which
I
one was that
made
one? Which one was the one that you just said? I'm sorry.
No, 19, I put 2.025 and I got it wrong.
So we probably have um,
Well, maybe we have the lower and upper bound wrong.
well, did you get those wrong? 21 and 22, or 20 and 21, did you get those wrong?
Oh, no.
Okay, so we have that right. So you got 19 wrong.
Yes.
Let me compute that again really quick. So 15.217 minus 11.168. 2.0245, so it's 2.025.
That's saying it's wrong?
It
Yeah.
said 0 points when I put down 2.025.
Okay.
Or
Maybe
if-
we're supposed to do that other formula for margin of error.
What is that other formula?
Where
the
it says,
The z of the alpha over the square root of n?
yeah. So then do we know what the standard deviation for this problem was? I think we did.
Which problem is this one? And I'll look it up.
Dissolved organic carbon.
Okay, let me look. Okay, dissolved organic carbon. And I'm looking, what am I looking for now? I found it.
You're looking for the standard deviation and n.
Oh, we need to have this, we need to open this up in SPSS, sorry. Let me see if I can get it. Does anyone already have this one open?
No. I exited out of all of mine.
Me too.
I have it open.
Do
You
you?
have it?
Yeah.
Can you tell us what the standard deviation and N are?
So just run an Explorer kind of thing, or just I guess descriptive analysis would be better.
Yeah, if you do then yeah.
Descriptives. Okay, so for n equals 20, mean is 13.193.
Okay. Okay, so I got 5.782.
5.782. And you did
I did 1.96 times 13.193.
over square root of 20?
Yeah.
Okay. We'll try it.
Okay. Which other one was wrong?
We got a few wrong here.
So
Or at least I
we're going
did.
up from 19.
Sorry. I was just starting to write down all the answers. So we were at 19. Okay, and then 18 is also I put down D, confidence interval for the mean difference using dependent.
Okay.
And that was wrong.
So what I had down before that was B. So I had,
The unknown.
what question is this for?
This might just be A because it's only one set of numbers.
Hey, you
Well,
guys,
I
I
don't-
need to leave in about 5 minutes or so.
Mhm.
Let me go ahead and tell you guys the rest of them that we got wrong.
Okay.
So 18 was wrong.
Mhm.
Just a second. 15, I put down fail to reject.
15.
That was wrong. And I think there's another one. There's a couple more. 12,
Mhm.
I put down B. I put down no, they do not have enough data
Okay.
in 12. Okay. And then 6, we must be doing something wrong with that margin of error, like the wrong equation.
Yeah, I
'Cause
think we should do the other formula.
I put down 1.96.
Okay.
Okay, for 6. And then let's see. Okay.
So that was it.
Yeah, like 7 questions or something we got wrong.
Yeah.
That's it.
Okay.
That's
All
nothing.
right. Okay. So let's go. So we already fixed 19, right?
What did we, what,
Okay.
hold on.
For
19.
19, we put 5.782.
19. Okay, got that.
Okay. For 18, what do we want to put?
Oh, let me see if I put a note on that one. What did we do?
More types. I'm
What
trying to-
number was that?
That was 15.
Okay.
We had pretty solid C on that one.
Let's go with confidence interval for mean when standard deviation is unknown.
You want to go for the unknown?
Deviation.
Yeah, because
Okay.
we don't have the standard deviation is not known, so yeah, let's do that one.
All right.
Is that A?
That's A, yeah. Okay. And then there's 15. So
What
for
was the
that
second?
one, we had
You had failed
it
to reject.
was D. Reject the null is the one we wanted before
Yes.
that Eddie told us. Okay, so 15 is D. Then we're going to do 12. So it's not, no, they do not have enough data. So the other one from that one was yes, it is enough that the data for each apartment building are bell-shaped.
They're not. It's not bell, but it can't be bell shaped because it's a right skewed only.
Well, can they?
Well, I guess it could be bell shaped because that means it's a normal sample.
Yeah, well, they're not talking about the ANOVA test, are they? I think they're just talking about the just how it's normally distributed throughout all 4 apartment buildings. Let's try yes on that one.
On um,
C on 12,
let's see.
and then
Da, 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 da. Yeah,
okay.
yeah.
So the margin
There's
of
a few
error. Okay,
outliers.
0.96 times 2
What is the
squared.
formula for 6 again?
It is 1.96 times 2 over the square root of, I don't think they gave us a sample size. Oh, 4. I got 1.96 again.
And that's wrong.
Oh, yeah, apparently. Let me try 1001.96 minus.
Yeah, because 2 over the square root of 4 is 0.
Okay, I got 6.96 after doing the other way.
What numbers did you use? The 1.96 times.
Oh no, for doing that, I got 1.96 again.
Yeah.
So this time I did upper bound minus lower bound divided by 2.
And you got 6.96.
I got 6.96.
Okay.
6.96. Well,
You guys, if one of you, what I've done before is when I go into my attempts and I copy my entire quiz, and then you guys could plug that in after you get it right, plug it into your email and email it to me. That'd be great.
Okay,
Because I have to head out.
sounds good.
Thank you, you guys. I appreciate you.
Yeah, have fun. Bye.
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 All right. I'll submit it this time.
Okay.
Did
Let's
you already
see.
submit it before, though?
No, I
No.
haven't. That was
Marjorie.
Marjorie.
Okay.
Oh, we missed question 24. Ah, dang. I have a comma. Okay, so need to fix 24. That one's probably, oh, and 23 is also wrong.
Oh.
23 and 24 are wrong.
She didn't say they were wrong on hers.
She did. Remember we changed it from the
Oh, yes, that's
approximate
right.
that we had?
So what's going on with this?
Ah.
Maybe we just used the wrong test.
Yeah, I'll put it up.
Okay, let me look at which other ones you got wrong. We got 19 wrong.
19?
So apparently we don't know how to do margin of error.
Weird.
Oh, well, 19 is dependent on 23 and 24, isn't it?
No. 19 is dependent on 20 and 21.
Okay. What did you guys have for question 7?
Let me look.
I have 998.040.
Okay, that's what I have, but it says it's a 0. Marjorie didn't tell us that one was wrong. And then 6 is wrong.
Well, that's because 7 is wrong. How is that wrong? Let's see. Let me look at the
Why is 8 right and 7's wrong?
998.040.
Wait, is it 998?
Yeah, 998.
Oh, I have 988.
Okay, it's 998.040.
0.040. Ah, dang it. Okay. Well, in that case, let me redo the margin of error really quick. It is 998 divided by 2. Okay, so you still get 1.96, so I don't know why that other one's wrong. You get the same answer both ways.
Both ways if you use the other one with the Z.
Yeah,
Huh.
I don't know.
The last time you said you had 6.96?
Yeah, but that's because I had a wrong number.
Okay,
So I got 1.96 doing the z-score way, and then 1.96 doing using the upper and lower bounds.
That's weird.
23 and 20. These are all. Why are those wrong? Okay, so for Hummers and New York and LA, do you have that pulled up, Eddie?
Which one? The Hummers?
Yeah.
Let me see. Yeah.
Okay, can you do a independent samples test
Okay.
to get the upper and lower bounds for that?
And it was independent sample t-test?
Yeah, independent sample t-test. We did a one sample t-test. That's probably why we got it wrong.
It was price for test variable, city code for grouping variable.
Mm-hmm.
And we get and which one do you want? What?
We want the 95% interval.
It is for the lower it was negative 769.741.
So the same answer we put in before.
Are we doing it for the Hummer one? Are we doing group 1 as LA and group 2 as New York?
Are the equal variances not assumed? Because
I don't
if
know,
not,
because we got
then
22 right, and it says confidence interval for the difference of means using independent samples. So we're doing an independent sample test.
let's see.
Can you switch them and maybe do like New York before LA?
Because it says in the thing to do LA is group 1. Does it matter?
Yeah, it does.
So
Is LA group 1?
yeah, LA is group 1 and New York is group 2.
Hmm.
I don't think it matters.
Doesn't?
But do we know the variances? Do you think they're similar or different? Because that also has a different number.
What are the variances that you have?
It says here for variances, you have negative 423.158 with an upper of 5417.256.
That is one of the options, actually.
Let's try that one.
So when it says true difference, does that mean variance then?
Variance is different.
Okay, so what is the lower bound?
The lower bound is negative 423.158.
23.158. Okay. And the upper bound?
5417.256.
256. Okay.
What was the lower one again? Negative. I have it 423 what?
0.158.
And what was it? How did you do the difference between the one we had with the negative 770? What was the difference that changed that?
He's looking at the variances this time.
Yeah, there's one that says equal variances. The other one that says variances are not assumed. Equal variances are not assumed.
Oh,
So which one was that one? What question?
23 and 24. Okay. I got a big margin of error.
I don't think we need the margin of error for
we
this
don't need a
one.
margin error for this one.
Is it 19 based on this one? Oh no, it's not. Just kidding. I lied. So how do you do margin of error then if we're getting it so wrong?
So 20 and 21 are right,
Yes.
but 19 is
19 is wrong.
how is that possible?
She posted some. Let me look at that really quick. She said, the margin of error is the amount we go above and below the point of estimate x bar m. X bar plus m. For this problem, we would like to take the upper bound of the confidence interval, subtract the lower bound, and divide it by 2. That's what we got. That's what we're doing. Huh. Does someone else want to try doing it? Maybe I'm just doing something wrong on the calculator.
I'm going to try it. Let's see. Hold on.
On which one?
I'm doing
On
15.217 minus 11.168 equals divided by 2. I have 2.0245. So I've been what we
it's
had
the same answer. Yeah.
What was it again? 15.217
I'm looking for it.
minus
So,
11.618.
Yeah, the upper bound is 15.217 and the lower bound is 11.168.
Yeah, I get same thing. Same thing. 2.025.
do you have a standard deviation and an n when you did your test? Oh, this
Yeah,
is for something different, isn't it?
I think this is something
This
different.
is for dissolved organic carbons.
Mhm.
I don't know what we're doing wrong.
Does it? Let me see.
Is the test value equal to 0? Because right here it says test value always equal to 0 when computing confidence interval.
Test value. I don't know.
Do the six. What question is this?
If standard margin of error. No, that should be it. If we're getting 20 and 21 right, 19 should be right. So it might not be what we're doing is wrong.
What if we round it up? Just put 2.
Let's try that.
Because I can't think of anything else that would make it wrong.
Which one? Which other ones are we fixing again?
We need to fix. So are we putting 2 for 6? Now we need to fix 19.
2 for 19, right?
Or are we doing 2 for 19? We are doing 2 for 19. We need to fix 6, which is the other margin of error question.
Let's put 2 as well.
Well, 1 point, yeah, let's put 2 there again.
Which one is this one? I'm sorry.
6.
It doesn't make any sense because if we have the other ones right, I don't understand. I'm like going through everything and I don't see how else to calculate a margin of error.
We're just rounding up to see if maybe that's what they want.
Wait. Smaller.
Did you figure it out?
Which of the following would produce a interval with a smaller margin of error than 90%? So would that be half of that 1.9 something?
I don't know. We can try it. You want to try it?
Sure,
What were you figuring out?
6.
We've already divided by 2.
But if we divide by 2 again, we get the lower half.
So 0.98?
Maybe.
I mean, it doesn't hurt to try.
Yeah.
So what are you putting? Are you doing that for 19?
For 6.
For 6.
So here it says find the sample mean. The sample mean is 1 millimeter or 1,000 millimeter. The lengths are known to follow the normal distribution whose standard deviation is 2 millimeters. So would it just be 4?
What is 4? The margin of error?
Yeah, I mean it says there the lengths are known to follow a normal distribution whose standard deviation is 2.
So 2 times 1.96 divided by square. We get the same thing though.
So 2, should we do 2 plus 2, which is 4?
We
Is
can
that what?
put 4.
Yeah, I'll put 4 and let's see what happens. I
Okay.
want to get it over with.
All right.
And is that all?
Yeah. It was 6, 19, 23, and 24.
Should I turn it in now?
Yeah,
Sure.
go for it.
Got a 90.
Hey, that's good. Do you want to read me all the answers? I don't really care to get 100, honestly.
Yeah, me neither.
An A is an A. Okay. All right. Donna, you have all the answers that we wrote down, right?
Yeah, well, Eddie has all the right ones, though.
Oh, that's right. That's right. Okay. So, read them to me.
Okay. 1 is true.
Mm-hmm.
2 is B.
B.
Yeah. 3 is C.
Okay.
4 C.
Mm-hmm.
5 D.
Uh-huh.
6 is wrong.
Okay. What did you
7,
put 4, right?
yeah, I put 4.
Okay. All right.
7 is 998.04.
98.04. Uh-huh.
8 is 1001.96.
1.96. Uh-huh.
That was 1001.96,
Yeah.
right?
Mm-hmm.
9 is 38.416.
There's a point?
Yeah.
Okay.
Why
Wait,
did I
what?
not have a point? I didn't have
That's
a
a good thing we're going over.
38.416?
Are you sure it's not a comma?
It might just be a comma that it put it on there for me. Yeah, it's a comma.
38. Yeah, I don't have a, I wrote that one down. There's no, okay.
Okay, so we don't have to put a comma. It's 38.416.
Yeah.
Yeah.
Okay.
10 is D.
Mm-hmm.
11 is B.
Mm-hmm.
C.
Mm-hmm.
A.
Yep.
A.
Mm-hmm.
15 is D.
Okay.
B.
Uh-huh.
D.
Yep.
A.
Mm-hmm.
19 is wrong.
What did you have?
Yeah, 2.
You put 2 down? Okay.
Yeah.
Just put 2. Definitely.
20
Okay.
is 11.168.
168. Huh?
21 is 15.217.
217. Mm-hmm.
22 I got wrong.
What'd you put?
B.
I have,
B.
I have C. What do you
Yes.
have?
I have B and it was wrong.
What did you put down, Catherine?
Let me open it up real quick. BYUI.
I had it down as C, but I don't know if that's the one that was wrong before.
Let me see. Because I don't think we got that one wrong initially. Okay. I'm logging in real quick.
When we started, we put B.
When we started, we put B? No,
Here,
I
let me
think
see.
we had unknown, didn't we?
No. When we started, let's see, when we started we had,
Submissions. Okay. So attempt 1. What question number is this?
22.
Okay, for 22, I had C, and that's right. Okay.
And that's the using independent samples?
Mm-hmm.
Okay.
Okay.
22 was C?
Yeah, 22 is C.
Okay.
23.
23 is negative 423.158.
158. Okay, so negative 423.158.
Yep.
Okay.
24 is 5,417.56.
Uh-huh.
0.256.
256. Okay.
And 25 is ANOVA.
Mhm.
26 is 7.978.
978. Uh huh.
27 is 0.002.
002. Mhm.
28 is D.
D.
Yes,
Okay.
dot.
Yeah.
29 is
Wait a minute.
E.
Does D as in there is sufficient evidence to conclude that the mean bone density of all three groups is about the same?
No, that's E.
A, B, C. Oh, I got it. Okay.
Okay.
As in dog.
Yeah.
29
29.
is E.
E. Okay.
30 is 1.685.
685. Uh huh.
31 is 0.096.
0.096.
And 32 is B.
32 is B. Okay.
So the ones that we got wrong were the margin of error ones, the two of
Yeah.
those.
Just two.
Yeah, so we just need to figure out how to calculate margin of error because apparently we suck at it.
That doesn't make any sense to me. Okay.
Yeah, I got a 93%.
Nice.
Yeah, it's probably just the one that you missed.
Mm-hmm.
Okay, all right.
All right. And who's going to send that to Marjorie? You wrote all the right ones down, right?
I can copy them down. Yeah, I'll just do what she said.
Okay. If not, I'll just copy and paste it and email it to her. Whatever you
Yeah.
want to
Okay, you can do that if you want. I didn't write them down physically.
do. Okay. All right.
All right. Bye.
All right, sounds
See ya.
good.